Greetings of the day, dear students. In this video, we are going to discuss about the active elements, passive elements, and also about the linear element, non-linear elements, bilateral element, unilateral element, and of course, you are not having in syllabus lumped network and distributed network, and some important points, right? Dear students, if you observe most of you in our DC circuit theorem statements, you will start with something like this. In any linear active bilateral network, like that we will start the theorem statement. Now let me understand what do we mean by that linear active bilateral or unilateral, all those terminology, right? In our electrical point of view, if it is an active element, any element that supplies energy, any element that supplies energy, right, it is to be treated as an active element. Example, if you observe, we are having voltage source, current source, and also the generator, transistors, right? They will all will supply the energy to the circuit, to the remaining elements present in the circuit, right? Like resistor, inductor, and capacitor, or some other elements. They are going to supply the energy to the circuit. Now, any element that supplies energy is called active element. Clear? Example, voltage source, current source, and generators, transistors, right? If you observe transistor, it will amplify the power of the signal. And dear students, observe transformer is not an active element because it will not amplify the power. Of course, it will step up or step down the voltage depending upon the voltages levels you have given. 11 kV can be made to 33 kV, or 33 kV can be made to some 11 kV, something like that. It will either step up or step down the voltages, but its overall power must be constant. Of course, there will be some losses. What I want to say is transformer is not an active element. It will not amplify power. It will transfer. What it will do, it will transfer the power from one circuit to the another circuit without any change in the frequency, right? So active elements examples are voltage source, current source, generator, and transistor, right? Now if any network, if it contains at least one active element, then you can call it as an active network. Clear? Now, what about passive elements? Opposite to that, right? For example, in our electrical circuits, we will be having elements which receives the energy or absorbs the energy, right? So here, if it is a resistor, the absorbed energy will be either converted or dissipated in the form of heat. If it is inductor or capacitor, they will store the energy. If it is a capacitor, it stores that energy in electric field form. If it is inductor, it stores the energy in magnetic field form, right? So here, these three elements, resistor, inductor, and capacitor, these three elements will receive or absorbs the energy, or these are the passive elements. Examples for passive element: if it is active element, a voltage source or a current source or some generators, like this, right? Now coming to the, if a network contains any at least one active element, right? It is if it does not contain, sorry, if it does not contain at least one active element, then it is to be called as passive network. You are having a, you are given a circuit diagram or network where there is no active element, at least there is no at least one active element, then you can simply call it as passive network. Passive network. Similarly, we will have linear elements. For linear elements, the key point is the characteristics for all time. should be a straight line passing through the origin. For example, if you have plotted for its characteristics, you should get a straight line passing through the origin. Then such kind of elements we can call it as a linear elements, right? For example, we are having a resistor, inductor, and capacitor. All those are the linear elements. If you observe, V directly proportional to I. If you remove the constant of proportionality, this is in the form of V equal to Ri, right? So this is in the form of some Y equal to Mx, a line passing through the origin with slope M. On x-axis you can take current, and y-axis you can take the voltage, and the slope of this line indicates the resistance, or which is a constant value, right? Similarly, flux phi directly phi equals to Li, right? Phi directly proportional to the flux established is directly proportional to the current flowing, and phi equal to Li. On x-axis you can take current, and y-axis you can take the flux. Then the slope of that line indicates the inductance L. Similarly, charge Q, capacitance C equals to charge per unit potential. Q, charge accumulated directly proportional to the applied voltage. Q equals to CV. If you plot the graph for voltage and charge, you will get a straight line passing through the origin. This indicates the constant of proportionality slope C. So similarly, voltage current relationships, if you observe like this, you should have a straight line passing through the origin, right? Now, V directly proportional to di by dt. If you remove the constant of proportionality, V equal to L into di by dt for inductor case. This is the case for inductor. And for capacitor, the voltage across capacitor is given by 1 by C integral I of t dt. If you are having a capacitor like this, if current I of t is flowing through the capacitor, then the potential across the capacitor is given by 1 by C integral I of t dt. So uh, this resistor, inductor, and capacitor, we can consider it as an linear elements, and it will involve a constant coefficient. In this context, it is R, L, and 1 by C, right? So these are the linear elements. Similarly, what about non-linear elements? Element is said to be non-linear if its characteristics for all time is not a straight line through origin. Is not a straight line through origin. For example, if you observe the diode, right? If you plot the VI characteristics for the diode and current and V, up to certain point there will be after breakdown only there will be sudden conduction in the diode depending upon the type of material, semiconducting material used. It will be either some 0.3 volts or some 0.7 volts depending upon the type of the semiconducting material you used, right? So up to certain point there won't be any conduction. All of a sudden there will be the conduction in the diode. Its characteristics is not a linear, a straight line passing through the origin. So diode, transistor, and tungsten lamps, all these will come under non-linear elements. Non-linear element, right? Similarly, we are having bilateral elements, bilateral and unilateral elements. How do you understand that? For example, if you are having a resistor like this, whether the current flows from A to B, if the current is flowing from A to B, or whether the current is flowing from B to A, in both the cases, the resistance offered by the resistor will be same. It will not change. It will not change whether the current flows from A to B or B to A. It offers the same impedance. It offers the same impedance for either the direction of the current flow. If you observe the diode, that is not the case. If you observe the diode, it is important whether the diode current is flowing from anode to cathode or cathode to anode. Based on that, the impedance will be different. Now I think you got the clarity. Diode is a unilateral element. Diode is a unilateral element. Similarly, for inductor, And the capacitor also, whether the current flows from A to B or B to A, the impedance offered will be same. The impedance offered will be same for capacitor also. Whether the current is flowing from A to B or B to A, the impedance offered must be same. And similarly for distribution lines, you will have the towers. The power will be transmitted through long distances, some 80 kilometers or 180 kilometers or 120 kilometers long length they will travel through transmission lines. Once they reach the substation with the help of distribution substation, right? And again from there onwards, distribution lines also will be running, right? So those lines and resistors, inductors, capacitors, all these are examples for bilateral element. Coming to the unilateral element, transistors and diodes are the example for unilateral element. The key point is the impedance offered must be same for either the direction of the current flow, right? Yeah. Now the next important of course this topic, lumped network and distributed network, you are not having in the syllabus, but understand, I will tell you. uh, for example, voltages and currents are the function of time only, right? Then it is to be called as lumped network. How do you understand this? It does not depend whether the current is at a distance of 1 kilometer or 2 kilometer from the source point. For example, if you observe the transmission lines, transmission towers will be there, no? They will be for a huge length, the lines will be running. Okay. Now, uh, the amount of impedance or current flowing voltage drops will also depends upon the distance, at what distance you are making the calculations. Not only time, the parameters of voltages, currents and the impedance resistance will also depend upon the distance, at what distance you are measuring these parameters. Then such kind of network is to be called as distributed network. If the voltage and currents are also depending upon the position. How do you understand this word position? At what distance, whether you are measuring these values at 1 kilometer or 2 kilometers or at some distance of 10 kilometers, like that, at what distance you are measuring, that distance also comes into picture, right? Where if it is a transmission lines or distribution network or transmission network, then it is to be called as distributed network. Lumped network, voltage and current are a function of time only, and they will not depend upon the distance. In lumped network, the network elements are physically separable. How do you understand this word? Really physically you will have a resistor element, or really physically you will have a inductor element. Really physically you will have a capacitor element. But if you observe the distributed network, I will say a 10 kilometers long line is running. Of course, it is made up of a conducting material, and the line itself will also have some resistance. Now I will represent that resistance like this. Do you think really it means really resistor is connected in this line? No. The equivalent resistance of this line is represented with this symbol, some resistance R of the line. And because of this line traveling long distances, because of the current flowing in this both the lines, some flux will be established, right? This flux cuts the remaining flux, and there will be some inductance effect also. There will be some inductance effect also for this line. Now, do you think that really there is a resistor and inductor in this line? No, its effect is to be considered. Really there is no any physical element like resistor, inductor, or with respect to the ground, there will be some capacitance effect also will come into the picture. Now this line, if I represent like this, it does not mean that really there are physically resistor, inductor and capacitor present in this line. You cannot separate that, but its effect will be there, right? Like that you have to understand. So dear students, observe, if the network elements are physically separable, but in a distributed network you cannot physically separate the elements. You cannot physically separate the elements, but its effect will be considered. For example, this line will have resistance. Its effect will be considered with representing with some symbol R. And this line will have some inductance and its effect will be considered considering with the letter some L. Okay, right? And also sometimes the capacitance effect also will come into the picture, right? Yeah. So examples are for distributed network, the examples are distribution line and transmission line are the examples for distributed network. Distributed network. I repeat again, these voltages and currents are function of time and position. Time and position. Position, how do you understand? The distance, right? Yeah. Now let me see some points, some brief points. Resistor, inductor, capacitor, which type of elements they are? Resistor, inductor, capacitor is a linear element. They will absorb some energy, right? They will not uh, deliver they will not deliver the energy. For example, active element, what it will do? It will not supply the energy. It is not going to supply any energy. Just they will absorb the energy. So it is a passive elements. Now bilateral, whether the current is flowing from A to B or B to A, impedance will be same. The impedance will be same. Z value, impedance of the inductor, capacitor and will be same. It is a bilateral element. So resistor, inductor, capacitor is a linear, passive and bilateral elements. What about diode? Is it linear? No, it is a non-linear element. Is it bilateral? No, it is a unilateral element. So diode, transistor are non-linear and unilateral elements. Like that we have to understand. Clear? Right. Now, of course, this graphs not required, but just have some idea. In this graph, observe, dear students, at origin, if you plot the graph between voltage and current, it is passing through the origin. At the same time, in the negative region also, negative voltage, negative current also, it is showing the same characteristics almost. It is a linear element. It is a passive element, bilateral in both the directions. Whether the current is flowing from A to B or B to A, it is offering the same impedance. If you take the ratio, impedance, how we will get that? V equals to IZ, Z equals to V by I. If you take either in the first quadrant values or third quadrant values, you will get the same impedance. Impedance will not change, so it is a bilateral element. Observe this graph, voltage current graph for some X element. We don't know what is that element. For X element, you got graph something like this. Is it a linear? No. Why? Because observe here the characteristics. Instead of getting a straight line, there is it is parallel to the current axis, negative current axis. Is it unilateral? If you take the ratio of V by I in both the quadrants, will you get the same Z value? No, you are not going to get the same Z value. So it is an unilateral element. Power product, V into I, positive value will get power. Here negative current, negative voltage. Here also if you take the product of V and I, you will get a positive value. Right? Here observe, is it a linear element? No, it is a non-linear element. Graph up to here linear only. But after crossing certain point of current, it has obeyed up to here only. But beyond that point, now the graph became non-linear. So it is a non-linear element, but bilateral. In both the cases, the impedance is same. Bilateral element, passive network. Observe this graph. Voltage and current is a non-linear element, active element. Voltage and current product, power, you are getting negative impedance. Impedance is negative value. V by I ratio, negative impedance you are getting, right? So it is a non-linear, active, unilateral element like this. Of course, this graphs not required for you. Just for some idea, I have discussed this graphs. But dear students, in any theorem statement, if you are starting with in any linear active bilateral network like that, right? Now you should be familiar with these words. Clear? Active element supplies energy. Passive elements receive energy. Linear element, straight line passing through the origin. Non-linear element, it is not a straight line passing through the origin for all time. Bilateral, whether the current flowing from A to B or B to A, the impedance will be same. Unilateral, the impedance will change depending on whether the current is flowing from A to B direction or B to A direction. Lumped network, voltage and current function of time only. It will not depend upon the distance. The elements are physically separable. Really, they will be existing, physically present. Distributed network, voltage, current, and they will be the function of time and also at what distance you are measuring them. Example, distributed network, right? So this is all the summary about the elements, right? Thank you.